Close your eyes. Imagine an old Earth. No cities exist yet. No paved roads exist yet. No trucks exist yet. No engines exist yet. No cranes exist yet. No steel exists yet. In many places, no wheel exists yet. There is forest everywhere. There are cliffs and boulders. There are rivers and marshes. There is sand and clay. There is rain that turns paths into glue. There is heat that cracks the ground. There is darkness, full of animal sound. People live close to danger. They hunt and gather. They move with seasons. They sleep light. They fear storms. They fear teeth, yet they also dream. They want a safe home. They want a high wall. They want a shrine. They want a tomb that lasts. They want proof that a group can endure. Stone gives that promise. Stone does not rot. Stone does not burn. Stone does not bow like wood. Stone is heavy. Stone is stubborn. Stone is the first enemy of builders. One small group finds a boulder. It lies near a slope. It is bigger than a man. It is bigger than a deer. It feels like part of the hill. The leader points to it. He says it will be a cornerstone. People gather around it. They push with hands. Nothing moves. They push with shoulders. Nothing moves. They dig around the base. Nothing moves. They pull with vine and fiber. The rope bites into skin. The knot slips once. The stone still does not move. The group grows tired. Some people curse. Some people laugh at the idea. Some people think spirits placed it there, but one person watches the ground. He watches what moves on its own. He sees a fallen tree trunk. It rolls downhill after wind. It does not scrape like a block. It turns and turns. It travels far. It is heavy too, yet it moves. He tries to stop it. He feels its weight. He also feels how little force guides it. He learns the difference. Sliding fights friction. Rolling reduces friction. He does not say friction, he just feels it. He returns with a plan. He says they should not drag the stone. He says they should make it roll. People cut several trunks. They choose straight ones. They trim branches away. They make rough cylinders. They clear a short track. They use a long pole as a pry bar. They wedge a small rock under the pole. They push down on the far end. One corner of the boulder rises a little. They shove the first log under it. They repeat the lift. They add another log. They add a third. Now the boulder rests on wood. It no longer rests on soil. They tie rope around the boulder. They tie rope to a pulling line. They line up in front. Someone calls a rhythm. They pull together on the count. At first the rope stretches only. Then the boulder shifts. It moves a finger width. Then it moves again. The logs rotate under it. The ground does not grind it anymore. The boulder begins to travel. The group freezes for a moment. Then they shout. They pull again. The stone rolls forward slowly. It looks impossible and simple at once. They learn the next lesson fast. The rear log comes free. The stone leaves it behind. Two people grab that log. They run it to the front. They place it under the leading edge. The stone rolls onto it. They repeat this cycle. Few logs can move a huge load. This is a relay. It is also a system. It is the ancestor of rollers. It is not perfect. It works best on flat ground. It works best on firm soil. It fails in deep mud. It fails on side slopes. A log can shoot sideways. A log can sink. The boulder can tip. The rope team can stumble. The group learns that terrain decides everything, so they change the tool again. They choose control over speed. They build a wooden frame. They use two long runners below. They attach cross pieces above. They make a flat deck. The shape is like a sled. It has no wheels. It spreads the load. It keeps the stone stable. They use levers again to lift edges. They place small rocks under the stone. They lift and block. They lift and block. This is cribbing. It is slow and safe. It is used even today. When the stone is high enough, they slide the sledge under it. They lower the stone onto the deck. They lash it down with rope. Now the load and the frame move together. They pull the sledge forward. It slides instead of rolls. Sliding is harder than rolling. It creates more friction. But it gives more control. It also works on rougher ground. It can cross small dips. It can cross mixed surfaces. The group still struggles. The runners dig into sand. The runners snag on roots. So the path becomes part of the plan. People walk ahead with sticks. They clear stones. They cut roots. They fill holes with gravel. They lay brushwood. They lay planks if they have them. They pack soil by stomping. They create a track. Sometimes they build a timber trackway. That means long poles laid parallel. It means cross pieces nailed or tied. It creates a smoother lane. It reduces sinking. It also guides the sledge. It keeps it from drifting. In wetlands, such trackways are known archaeologically. People use them for crossings. Heavy hauling likely used similar ideas. The group also discovers lubrication. It happens by accident first. Water spills on sand. The sledge moves easier. The team feels it at once. The runners stop plowing so deeply. The sand ahead does not pile as high. They try again on purpose. They wet the track. It works. In dry sand, grains behave loose. They shift and flow. They build a ridge ahead of the runner. In slightly wet sand, grains bind. They compact under pressure. The runner rides higher. The force needed drops. This is not just a guess. It is supported by experiments. It is also hinted in ancient art. A Middle Kingdom Egyptian tomb painting shows a huge statue on a sledge. It is being pulled by many men. A figure pours liquid in front. The tomb is of Jehuti-Hotep at El Bersheh. Many researchers interpret the liquid as water. The purpose fits physics. The purpose fits hauling practice. The image is not a modern diagram, yet it captures a real technique. People also used mud and clay slurries. They could reduce scraping too. In some cases, animal fat could help. Fat was valuable though. Water was easier. The group learns another trick. They use wedges. A wedge is a simple machine. A wedge can lift a load slightly. A wedge can lock a load in place. A wedge can also split wood. It can also split stone along a line. Early wedges can be stone. Later wedges can be copper. Later wedges can be bronze. Later wedges can be iron. The principle stays constant. Downward force becomes sideways force. That helps quarrying. Quarrying is where transport begins. You cannot move a block you cannot free. People free stone by exploiting natural cracks. They hammer with stone mauls. They drive in wedges. They sometimes use dry wooden wedges. They then soak them with water. The wood swells. The crack widens. The block loosens. This method is documented in many traditions. Not every quarry used it, but the physics is real. Once a block is free, the transport problem returns. The team must load it. They must lower it. They must keep it from shattering. Stone is strong in compression. Stone can be weak in tension. Sudden drops can crack it, so they use cribbing again. They build small stacks of wood and rock. They lower the block step by step. They also use earth banks. They can roll a block onto an earthen pad. They can slide it from there. Earth is a cushion. Earth is also a ramp. Ramps become the main tool for height. A ramp is an inclined plane. It trades force for distance. You pull farther. You pull with less force at any moment. You also gain control. You can stop and block the sledge. You can wedge it. You can rest. Ramps can be straight. They can go up one side. Ramps can zigzag on a wall. They can reduce slope. Ramps can spiral around a structure. They can also be rebuilt in stages. The ramp itself requires labor. It needs fill material. It needs compaction. It needs edges. It needs maintenance after rain. It needs a stable surface. It may need timber reinforcement, yet it uses cheap material. Dirt is everywhere. Rubble is everywhere. That is why ramps make sense. They are the most accessible lifting machine before cranes. The lever remains vital on ramps too. A sledge may need tiny adjustments. A block must seat perfectly. A lever can shift it a few centimeters. That is often enough. The rope becomes the silent hero in all of this. Rope is not simple string. Rope is engineered fiber. It must hold tension. It must resist abrasion. It must resist sudden shock. It must survive heat and sun. People made rope from plant fibers. Flax is one source. Hemp is another in some regions. Bark fibers can work. Reeds and grasses can work. Leather strips can work too. The fiber must be twisted. It must be laid in strands. It must be braided into a line. Knots must be reliable. Lashings must be tight. The load must be wrapped so it will not slip. Sharp stone edges can cut rope, so padding matters. Wood strips can protect rope. Fiber mats can protect rope. Sometimes grooves were cut for ropes. Sometimes wooden frames held the ropes off edges. This is rigging. Rigging is a craft. It appears wherever heavy loads appear. The other hero is organization. Physics alone is not enough. 100 people can be weaker than 50 coordinated people. Pulling must be synchronized. If one row pulls early, the rope jerks. A jerk can snap a fiber rope. A jerk can make people fall. A fall can pull others down. So leaders call time. Work songs create rhythm. Chanting creates shared timing. Drums can help too. A supervisor watches the sledge. Another watches the track ahead. Another manages wedges and brakes. Another manages water on the sand. Another checks ropes for fray, another repairs the sledge runners. A heavy move becomes a ceremony of roles. This is how big projects train societies. They require planning, they require supplies, they require schedules, they require trust. They also require safety habits. Loads can slide backward on slopes. So teams use chocks, they use stone wedges behind runners, they use wooden blocks, they stop often, they rest often. They also plan for failure. They keep spare ropes. They keep spare poles. They keep spare runners. Distance creates a different challenge. Land hauling is slow. Land hauling is exhausting. So ancient people used water whenever possible. Water reduces effective weight through buoyancy. A barge can carry what a sledge cannot. So rivers become transport corridors. This is why many early civilizations align with rivers. Egypt has the Nile. Mesopotamia has the Tigris and Euphrates. The Indus region has major rivers. China has the Yellow River and Yangtze. Timber and stone can move downstream. They can move on rafts. They can move on barges. They can move in boats with wide beams. Sometimes a barge is pulled from shore. This is towing. Sometimes it is sailed. Sometimes canals are dug. Canals connect quarries and sites. The final segment often returns to land. The load is landed at a bank. It is shifted onto a sledge. Then it is hauled again. This mixed transport is efficient. It is also plausible. It matches geography. It matches known ancient shipping practices. Now the story reaches famous monuments. Think of megalith sites. Think of stone circles. Think of dolmens. Think of long barrows. A heavy stone can be raised without cranes. A pit is dug first. The base of the stone is placed near the pit. The stone is tipped so the base drops in. Ropes pull the top upward. Levers can assist at the sides. The stone pivots into a vertical stance. Then the pit is packed tight. It is packed with smaller stones. It is packed with earth. It is tamped hard. This locks the monolith in place. Then a lintel stone can be placed. An earthen ramp can reach the top. A sledge can bring the lintel up. The lintel can be slid into position. Then the ramp can be removed. This method is simple. It is labor-heavy. It is realistic. It is used in experimental archaeology. It explains many settings. Stonehenge is often discussed this way. The exact routes for each stone are debated, but the toolkit is clear. Rollers are possible for some segments. Sledges are possible for many. Timber trackways are possible. Water transport is possible for parts of the journey. Raising is possible with pits, ropes, and ramps. The same applies to many other megalithic builds. Different landscapes create different mixes. On an island, sea travel may dominate. In a river valley, barges may dominate. In forest zones, rollers may dominate. In deserts, sledges and watered tracks can dominate. Now shift to Egypt. Picture the Nile Valley at dawn. The sun is still low. The air is cool for a moment. Work crews wake early. Food is organized. Water is carried. Tools are checked. Ropes are inspected. Sledges are repaired. Quarries operate in systems. Blocks are extracted. Blocks are shaped roughly. Faces are dressed later. Some limestone is local. Some stone is shipped. Hard stone like granite can come from far south. The river makes that possible. At the building site, blocks arrive in steady flow. The goal is not one heroic pull. The goal is thousands of controlled pulls. Teams haul blocks on sledges. Tracks are prepared. Sand can be wetted. Pulling lines are organized in rows. Rhythm is kept. Stops are planned. Wedges act as brakes. Levers shift blocks into final alignment. Ramps or embankments give access to higher courses. The exact ramp designs for pyramids are still debated. Multiple ramp strategies may have been used. Straight ramps are possible early. Side ramps are possible later. Spiraling ramps are possible. Internal ramp ideas exist too. What is not debated is the physics. A ramp allows lifting without cranes. A sledge allows hauling without wheels. Water transport reduces long-distance effort. Levers enable precise placement. Organization makes it repeatable. Later cultures add more tools. Wheels appear in some regions around the 4th millennium BCE. They help on good roads. They help on firm ground. They fail in soft sand. They fail in deep mud. That is why sledges stayed useful even after wheels existed. Later still, pulleys and winches appear widely. Capstans can multiply pulling force. Multiple pulleys can multiply mechanical advantage. Greek and Roman engineers built cranes. Some used tread wheels. Humans walked inside a big wheel. The rope wound up. The stone rose. Those are later steps. They do not erase earlier methods. They build on earlier ideas. The core logic never changes. Reduce friction, spread the load, control motion, use simple machines, use water when you can, use ramps for height, use ropes for force and safety, use levers for precision, use wedges for braking and splitting, use teamwork for timing, use leadership for coordination. That is how early humans moved massive trunks. That is how they moved massive stones. That is how impossible work became routine. That is how monuments began. That is how engineering began. And that is how a world without wheels still learned to move mountains, one short pull at a time.